we start talking about functions. Right now we will talk about the basics of functions. So function is a very, very important concept. Okay, and of course their graphs. We learned a little bit of the graphs before, so we're gonna do this. All right, function. How do I explain functions to a student? I would think this function is a magic box. This is called a function. Okay, and here is something you need to drop in something, and then it will come out something. So magic box means you put in something, you shake it, okay, let it function, and then you come out something. So whatever you put in called input. That makes sense, right? And whatever comes out is called output. Just instead of saying putting a coin come out an apple or come out a ticket. And here in math, our input and output both are pretty much numbers. Okay, so this is like the relationship. So input and output. Okay, input, output, input, output. But sometimes input, output, well, if generally speaking, it doesn't necessarily to be a number. Okay, for example, I put in this. I put in a 1 and come out a 4. Okay, I put in a 3, come out a 10. For some so for whatever reason, okay, putting a 5, come out and 16. All right, so this is how this magic box or this function works. Or we also call this as a relation. When we talk about a relation, the relation we always do like ordered pairs, okay, which means input then output. Okay, don't be confused about this comma here, and sometimes it could mean a xy coordinates in the xy coordinate plane, and sometimes it just means it's a paired relationship. For example, this one, this is a relationship. Okay, so that is 1 4, okay, 3 10, and 5 16. That is one relation. And let me give you another one. Okay, input output. Okay, so I give you input Toyota, come out Highlander. Okay, I input Honda, come out a Pilot, and I input Ford, come out Explorer, and I input a BMW, come out X5. Okay, you see, they are paired. Toyota Highlander, Honda Pilot, Ford Explorer, BMW X5. So you put in the car make, and then what comes out is one kind of an SUV comes out, isn't it? Okay, so one more. Another one, I want to show you the relationship. Okay, so y equals 2x plus 1. You put in any x, what comes out is y, that is 2x plus 1. So if you put in 3, you put in here, you shake this function, this equation, this function, you shake it, you get 2 times 3 plus 1, so 7 comes out. Okay, so this is a relationship. All right, now after we know this relationship, then there's more concepts. Whew, I know. So for input, sometimes we use, or most of the time we use an x to show that, and then we also call that independent variable. Okay, and the whole set of x is called a domain. Okay, very similar. Output, we use y, and that will be called a dependent variable, because y will depend on x and the set of y. What does that mean? That means all the possible y values. All right, now I want you to remember all those. So every time later, when I mention domain, you know what the domain is. Domain is what x number or x value could be, or the whole set of x value is called a domain, and the whole set of y is called a range. Now look at this relationship. I only give you this relationship. Okay, I only give you this. And what is the domain? Domain is about x. Domain is what x value can be, or what input can be. So the domain is 1, 3, 5. The range is 4, 10, 16. And this one, what is the domain? Domain is Toyota, Honda, Ford, BMW. What is range? Range is a Highlander, Pilot, Explorer, X5. Okay, now this one. What is domain? Domain is what x value could be, right? All the whole set of the possible x values. So that domain all real numbers. Okay. You can also do like this using the interval notation from negative infinity to positive infinity. This is the interval notation. This is not the xy coordinate. Okay, so be very careful with that. This is the interval notation. What about the range? Okay, the range is also all real numbers or values, the same thing. So x can be anything, and y, range, y, all the possible y values, that's the all real numbers. Okay. All right, now for the interval notation, remember I just put here negative infinity positive. This is called an interval notation. Okay, interval notation. There are 4 type of interval notation. You have, I just use 1, 3 as example, and 1, 3 bracket or parenthesis, 1, 3, and 1, 3. You see that? See the difference? Okay, so this one means for this number line, here's a 0, here's a 1, here's 2, here's a 3. This means from 1 to 3. This is an interval notation. Again, this is not in the 2-dimensional space, not the xy coordinate. Xy coordinate is always parenthesis, and also it will tell you that's a coordinate. But this one is interval notation, so that's on the number line from 1 to 3. There, right? From 1 to 3. Okay. But this bracket means including 1. Parenthesis means does not include 3. So this is the right way to show this interval. So sometimes the domain or the range, you have to use interval notation to show that. And this one, okay, 0, 1, 2, 3, 0, 1, 2, 3. From 1 to 3, but it's bracket, so that means it's including, and just shade this interval. Okay, and this one, that would be x 0, 1, 2, 3. I think you already know. 1 and 3, both a parenthesis. Okay, and the last one. Okay, 0, 1, 2, 3, 1, 2, 3. Including 3. 3 could be there, but not 1 is a parenthesis. So we use a little circle to show. All right, so this is the basic idea about the interval notation. All right, now after we learn all those important concepts, we go to the real most important one, function. We use this to show function. Okay, y is a function of x. X is input or independent variable, and y is output, the dependent variable. This one shows the function. This is a function notation. Now, how do you know whether a relation is a function? How do you know whether it's a function? Okay, I tell you that the most important concept is for any given x, for all the possible x, there is only one y for n x. All right, only one y. Now, let me ask you this. Do you remember this? Y equals 4 minus x squared. If you remember, we have the graph look like this. We learned a little earlier, right? For each x, there how many y? For each x value, we give x value here, and then when we do the calculator, there is only one y. So it is a function, okay? And this one, y equals x plus 1. I don't know if you remember this. This is the graph that we had earlier. Okay, for each x, there's only one y, so it is, okay? All right, what about the next one? X squared plus y squared equals 4. For each x value, for example, let's say when x equals 0, to see what happened. When x equals 0, 0 squared plus y squared equals 4, so this is nothing. And y could be 2 or positive 2. So that's not a function. So this equation doesn't really show a function, okay? This equation is not a function. Interesting? So you plug in x, you can get y from that magic box of function. All right, now, again, what is a function? Function is to shake the box, right? The function is to shake the box. So let's see. If you put in f of x, or we say y, right? Or we go y equals x squared minus 5. If we know this, then is this a function? For given any x value, you square it, you minus 5, you get a y. So yes, it is a function. It's a function. All right. And also we call this y equals f of x equals x squared minus 5. So this is a function. Is a function. Let's say, how should we shake the box? We drop in a number, x, we shake the box, okay? We let it do something, and what it do? What it does is x squared. It square it, and then it minus 5, and then drop out the number. So when x equals 5, f of 5, the function of 5 equals 5 squared, 25 minus that is 20. So you drop in a 5, you come out a 20. You drop in a 10, f of a 10 will be 10 squared minus 5, which is 95. 10 squared is 100. It's 100. So I can do it this way. So be very careful here. Look, I go f of x equals x squared minus 5. But this x can be anything, right? I can put this x in an envelope. Okay, whatever inside, and what it comes out is going to be this envelope get square and then minus 5. So that's the function concept. A function of something. You have to do the same thing to whatever input there. Okay, so if I put in f of m, okay, instead of saying x, I drop in m. What do you have? You're going to use this m to substitute this envelope. So it's going to be m squared minus 5. That's how it works, okay? Now, if you get this concept, then let me ask you, what is f? F of x minus 1. This is fx. We don't know what is fx minus 1. So you should treat this as the guy in the envelope. So what you should have is x minus 1 whole thing square minus 5. Compare this with this one. This is the core understanding. This is most important understanding for function. In math, of course, I will just use letters, but actually it can be just not a single letter. It could be some expression. All right. So that will be, you put here x minus 1 squared minus 5. Okay? So think if you can understand that. Now let me ask you a very tricky question. If f of x equals 2x plus 1, what it says is, for any given x value, what you need to do is you double it plus 1, right? So for this f of 1 will be 2 times 1, 2 times 1 plus 1, which is 3. So f of, I can put in this, I call this envelope or box or whatever. That'll be 2 times this, then plus 1, right? So that's a function. Now, tricky part comes, what is f of this guy? This guy, okay? Whatever you put here, you can use apple, you can use a flower to show whatever input is. What comes out is twice of that guy plus 1. So that's 2x plus 1. You have to put 2x plus 1 in the box, and here comes out 2 times 2x plus 1 plus 1. Right? F of something is twice of that thing plus 1. Of course, you can simplify, you use the distributive property, you get 4x plus 2 plus 1, and then combine like terms, you get a 4x plus 3. So if I give you f of x equals 2x plus 1, if I ask you what is f of 2x plus 1, the answer is 4x plus 3. Okay? Just one more. F of x equals 2x squared minus x plus 8. I just make this up. I ask you, what is f of 2x? Can you do that? So you rewrite this, f of something equals twice of this thing squared minus this thing plus 8. And then you just need to put a 2x, 2x, 2x here. So that will be twice of 2x squared minus a 2x plus 8. And 2x squared is a 4x squared, and times 2 we got 8x squared. If you don't know how to do it, be very careful. 2x squared is a 4x squared. Here, 2x squared, which is 2x times 2x, which is a 4x squared, right? And then you times 2, you get that. And then minus 2x plus 8. That's your answer. Okay? All right, now, again and again, for each given x, there is only one y value. What does that mean? We have a graph. We have a graph of a function like this. Okay. For each given x value, there's only one value. For each given x value, there's only one y value. So think about this. If for given x value, you look at it vertically, and your pen or pencil should only touch the graph once. If you touch it twice, then that means, for example, if I have a graph, it looks like this. Okay. For this given x value, how many possible y's are there? 1, 2, 3. You have 3, right? For this given x value, you touch here and touch here. So you have two y values. So in this case, this is not a function. So we should use a vertical line test. This is very easy. You just hold your pen and go from left to right, or from left to right, it doesn't matter, and to see how many times you're going to touch your curve. So I will give you a lot of different. This one, I give you the graph of I give you this graph of an equation. Is this a function? You use your pen. You see here, you touch them twice, right? A lot of places you touch them, so this is not. Okay, what about this? What about the straight line here? If you go from left to right, hold your pen vertically, you only touch the graph once, so this is right. Okay, what about this one? Yes. What about this one? Yes. Okay. What about this one? No touching, that's okay, but no more than one, okay? So here, woo, you get two, so that's not good. A couple of more examples. Hold your pen vertically, that's a function. Okay. What about this? Nope. No. Okay. What about yes. And what about no? Okay. What about the snowfall? Yes. That makes sense, right? At any particular time, there could be only one measurement of the snowfall in inches, right? You cannot say when the snow started after 5 hours, there are like 7 and 8 inches. No, there's only one solution. So that is a function. So that's a general idea about this. And it's very, very easy. I think right now you know how easy it is. Just hold your pen vertically and move from left to right to see how many times you're going to touch the graph. And then you're going to determine whether it's a function or not. Mathematically, we're going to say for a given x value, there's only possible one y value. Okay, and for all the domain, for all the x value, for the x value in domain, remember domain is the whole set of all the possible x values. For any given value in domain, there's only one y value. Okay, then that's a function. Okay, now let's quickly review what we learned today. We learned the basic concepts of the functions. We learned input, output, shake the magic box, and we get the relationship input, output, and we have a special term for that. We have input, output, x and y, independent variable and an independent variable, and the whole set of x is called a domain and the range. We're going to use this a lot. And we learned something about the interval notation, and we learned the function notation, how to write it. And then we use this to understand the real concept about the function, and we did some practice, and then we tried to use the vertical line to test whether a graph of an equation is a function or not. So that's what we are doing for this class.